Hello Year 11s, welcome to the next lesson. Okay, so we're working on 14H today, so solutions of trig equations. Okay, so we're going to work out how to solve equations and find multiple solutions. Okay, work straight into an example. Okay, so for this example, we need to find the exact values of x. So where sine of x is equal to square root 3 on 2, okay, within the domain of 0 to 2 pi. Okay, so one revolution of our unit circle. Okay, so what we need to think about, first of all, is the answer before we bring sine across. Okay, think about what answers we're trying to find. Okay, this is a positive square root 3 on 2. Okay, because this is a sine function, we're trying to find which quadrants sine is actually positive. Okay, remember sine is the vertical component. Okay, so remember when we do our casting. Okay, so C-A-S-T. Okay, so we're trying to find which quadrants sine is positive. Sine is positive in quadrant 1 and quadrant 2. Okay, so 1 because they all are, and 2 because sine are, because it represents the vertical distance. Okay, so what we need to do is, what we're actually going to find out is we're actually going to have two solutions. Okay, we have two solutions to this within this whole range here. Okay, so to find our answer, what we do is underneath, I'm going to bring sine to the other side. Okay, so x equals sine inverse, okay, of square root 3 over 2. Okay, so we're going to find multiple solutions. Okay, so once we've done that, what we need to work out is, okay, inverse sine of 3 on 2 is a value that we're trying to find what angle we're trying to find. Okay, remember x is representing our angle in this case. If you refer to your little exact value slip, okay, that I've got there, everyone should have a handout of that. You'll find that sine square root 3 on 2 is actually pi on 6. Okay, or pi on 3, sorry. Pi on 3, not pi on 6. Give me 2 seconds. Okay, so it's actually pi on 3. That's the first solution. That's the solution that we find in quadrant 1. Okay, we know that sine is positive in quadrant 2. Okay, so and remember in quadrant 2 when we're working with sine, this is sine pi minus our angle. Okay, so this is sine pi minus pi on 3. Okay, which becomes sine of 2 pi on 3. Okay, so that will be our next solution. Okay, next solution is actually 2 pi over 3. And these are our two answers that we get. Okay, what this actually means is when we graph this function, okay, when we graph sine of x, okay, as we go up, down, up, okay, the value that we have, square root 3 over 2, okay, that's just below 1. So square root 3 on 2 over here, over 2. So it's approximately 0.866. Okay, so if you put that into your calculator, so it's just below 1. So if you think about that value, as we work our way across, okay, so for one full revolution, when this is 2 pi, remember our domain runs from 0 to 2 pi, we actually get two solutions. And those are the two solutions that we found. The first one being pi on 3, and the next answer being 2 pi on 3. Okay, and that's what we're trying to find. So we need to always work out how many solutions that we need to find. Okay, I'll touch on a few different examples as we move on. As we move to our second question, we've got our function of square root 2 cos 2 of x plus 1 equals 0 within the domain 0 to 2 pi. Okay, so there's a couple of things that we need to touch on. The first one that I'm going to touch on is the 2x in the middle. Okay, because in the previous example, the value of the number in front of the x was 1. Okay, so we didn't have any dilation from the y-axis. Okay, so remember that represents, if my pen wants to work, my dilation from the x-axis. Okay, so that's my dilation from the x-axis. So what you're going to find is our graph is actually shrinking. Okay, so every value is going to be halved. Okay, so what I'm going to do is I'm going to find my period. Okay, my period is 2 pi over n, which in this case is 2 pi over 2, which is pi. Okay, so that means my period is pi. If I've got this over the domain of 2 pi though, I'm actually going to get more answers. So in the previous example before, we only had 2 answers. Okay, so we get 2 answers. In this instance, we're actually going to get 4. And part of the reason is, if I draw my cos graph up here at the top, okay, cos starts there. Just wants to work, yeah, so we work our way down, up, down, up. Okay, what you're going to find is, remember when we said our period was pi? Okay, that's that location there. Okay, that's the time it's taken for 1 full revolution. In this case, we've actually got 2 periods, okay, or 2 full wavelengths, depending what terminology you want to use, okay, and that's within our domain. So, first of all, what we need to do is what answer we're trying to find, okay. If I rearrange this equation that I've got up here, I'm going to go square root 2 cos of 2x, okay, is equal to -1. So I've just brought that positive 1 across to the other side. I'll bring that down to cos of 2x, okay, equals -1 over square root 2. Okay, so I'm trying to find where the value is -1 over square root 2. If you put that into your calculator, that's approximately 0.707. Okay, remember how we said our amplitude up above and below is square root 2, okay, and negative square root 2 with our graph. Square root 2 is approximately 1.41, okay. So if we're at 0.7, we're about halfway. We're about right in the middle there, okay. So if we're negative -1 over square root 2, what we're going to do, as I trace this line across, what you're going to notice is I actually get 4 answers. I get 1, 2, 3, and 4. Okay, so I'm going to get 4 different answers. And this is why it's important to find your period. Okay, to find your period. So what we're actually going to do, see how this is cos of 2x. Okay, previously our domain was represented as x. What we're going to do is we're actually going to expand our domain temporarily. Okay, and I'll show you how we're going to change that. So instead of writing x down below, I'm going to write 2x. Okay, this is going to be less than equal to there. And what I'm going to do is I'm going to multiply my minimum and my maximum by 2. Okay, so this becomes 0 times 2, which is 2. And then my maximum domain is actually, I'm going to go 0 to 4 pi. So that means when I bring this cos across here and try and generate my values for -1 square root 2, I'm actually going to generate the values between 0 and 4 pi. Okay, it's important because that's going to give me my 4 values. And then I can rearrange afterwards to find what I get, okay? So if I go to inverse, so if I'm going 2x is equal to cos -1 of -1 over square root 2, okay? I need to find where cos, the angle that cos is -1 over square root 2. So if you refer to your little diagram that you've got there, what we have is cos. So if you look at the column with cos, and we trace down to where it's 1 over square root 2, what you're going to find is it's actually pi on 4, okay? But because we're finding negative, we need to find what quadrant's -1 on square root 2 is. And -1 on square root 2, where cos is negative, are those 2 sections. Remember, CAST, okay, it's my way with cast. So cos, all, sine, and tan. So sine and tan are positive, but I know in here, cos is negative. Okay, and that's what I want. So in this section, we've got cos. Cos of our angle is negative. Okay, and the same with that one there as well. Okay, so they're both negative. So they're the quadrants I'm looking at. That equals pi on 4. Okay, naturally, if it was positive, it'd be pi on 4, 45 degrees. Okay, or pi on 4. In this case, it's going to be the other 2 angles. Okay, so it's actually going to be, our answer will be 3 pi on 4. Okay, so 3 pi on 4. Remember, it's always subtract our pi on 4. So we're going pi minus that pi on 4, and then we go pi plus the pi on 4, which will be 5 pi on 4. Okay, so they're going to be our first 2 answers in quadrant 2 and quadrant 3. But now remember that we're using our period of 4 pi. So instead of our unit circle over here, instead of going around once, we're actually going around twice. Okay, so we need to generate our values from that. Okay, so if I've done one full revolution, that's 2 pi, and I'm going to plus, so 2 pi, and I'm actually going to plus 3 pi on 4 to find that second value that I have at that location. Because we're going to have 2 values at that exact same point if you think about it in a unit circle. So 2 pi over 4 is actually 8 pi on 4, so 8 pi on 4 plus 4 is 11 pi on 4. Okay, and then I'm going to find my second value in that third quadrant. And in that third quadrant will be, as you can see, the relationship from there to there. I've just gone plus 2. Okay, the same from there to there is you're also going to plus 2 as well. So this becomes 13 pi on 4. So these are my 4 values that I've generated. They're not my finished values because they're equal to 2x. What we need is I need to find my angles equal to x. Okay, so what I'm going to do is I'm going to bring that 2 to the right hand side of the equals, and I'm going to divide every single value by 2. So this becomes 3 pi on 8, 5 pi on 8, 11 pi on 8, and 13 pi on 8. And those are my values. Okay, those are my values that I found up here. So that first one there, that location is at 3 pi on 8. The next one, so that first one is at 3 pi on 8. That next one is our 5 pi on 8, so 5 pi on 8. My third value is our 11 pi over 8. And my last value is 13 pi over 8. Okay, so this does involve a little bit of practice. I'll give everyone a handout of how to solve these. I'll place these on Compass for your class on Monday. Okay, but I'll print them off when I see you first on Tuesday. So I'll print them for you, but they will be on there. And it gives you step-by-step instructions on how to solve these. So hopefully you follow these. They do take quite a bit of practice. Okay, they do take quite a bit of practice. Please make sure you're practicing them. Okay. Just a quick note before we move on. We can actually solve these using our calculator. Okay, so what I'm going to do is I'm going to show you how to enter these into your calculator. Okay, so what we need to do is we're going to use the solve feature. Okay, we're going to generate all these values. What I want to do is I want to enter this function to solve bracket square root 2 of cos bracket 2x close bracket plus 1 equals 0. So the exact same function that I have there in the PowerPoint. What I'm going to do though is I need to create a domain. Okay, otherwise if you think about the sine graph or the cos graph, remember the domain is all real numbers. So I'm actually going to generate an infinite amount of solutions. Okay, but what I want to do is I want a selective amount of solutions. So I'm going to go to the Math 3 section on our keyboard, and I've got a symbol there that is it's like a vertical line that represents given that. Okay, so given that. So what we're going to do is we're going to go square root of 2 cos 2 of x plus 1 equals 0. Given that, and we're going to enter our domain. So we're going to go 0 less than x less than 2 pi. Okay, so we're going to try and find our values within that domain. Close bracket, I hit equals, and I'm going to get these weird decimals. I'm thinking, what the hell? Okay, so what I can do is I can highlight that, go to our fraction tool, and we're generating those values. And those values are the exact same as what we found within the solution before. Okay, so we had 3 pi on 8, 5 pi on 8, 11 pi on 8, 13 pi on 8. So there are our solutions that we have. I've got the notes on how to repeat that process on Compass if you want to have a look. But that's how you generate those values. What you will need to watch out for is you can't rely on your calculator. Okay, remember one of your exams, okay, on your SACs, you need to be able to solve this manually and with the calculator. Okay, so if you do have your calculator, obviously this is going to be a significant shortcut. If you don't, you need to make sure that you do know the mathematical technique. Okay, it does involve quite a bit of practice. So see how you go. I'll be back in class on Tuesday. So hopefully by then you can ask me any questions that you have. Okay, so thank you. Hopefully this has been helpful, and I'll see you Tuesday.